Landboards presents Making Banana to Alligator Test Cables. A common cable to use is a banana to alligator cable. These cables are commonly used for connecting meters and power supplies to units and items you want to test. These cables are available from China quite cheaply, but the quality is also quite poor. There's no specification given other than the fact that there's a black and a red cable and it's about 18 inches long. Since the gauge on those cables is small, I prefer to replace the cable with 16 gauge silicone wire. It has a good feel when you're working with it, and being 16 gauge, it's quite a bit more capable of current capacity. This cable is fairly pricey even when you buy it from China, as you can see from the eBay listing. The cable does list quite a bit of specifications for it in comparison to the jumper cables. There are 5 meters of cable in this particular listing, red and black for 10 meters total. They come in red and black wires, which is obviously what we need. Current carrying capability of 35 amps, but most importantly I think is the silicone and the fact that it's 16 gauge wire. Quite a bit more current carrying capability. One of my favorite tools is this square electronics pliers. It's quite helpful for the sort of work we'll do to rework these cables. The squared off part really helps for holding material and working in this sort of electronics. In fact, you might say this pair of pliers at some point in time flew too close to the sun, or a soldering iron. One of the uses for the pliers is just holding wire when you're trying to tin it so it isn't moving around the table or you're not soldering to the surface of the table itself. It can even hold a couple of wires, and the sort of bend and square nature of the pliers really makes it easy. When you're reworking these kinds of cables, getting a grip onto the alligator end is really important, and clipping it onto the pair of pliers works quite well for that. Yeah, we bought these pliers from MCM at $5.50 a piece. They're well worth the price for sure. So let's take a look at what it takes to disassemble the cables and to begin to rework them. For the banana end, it's really just as simple as taking a screwdriver and unscrewing the screw. You don't have to take it all the way out, just enough to get the cable out. In this particular case, you can see when we pulled out the cable, it was tinned for the end of the cable, which probably isn't the best practice just because tinned solder joints can become loose with time. To take apart the alligator side, we clip it onto our handy pliers, which gives us something to hold on to as we're pulling the plastic shell back from the alligator connector itself. You can see for the assembly here that they don't bend the prongs over, and it's just a dab of solder that's holding it in. I think that's adequate, although I kind of would lean towards bending it over. To remove it, just simply desolder the cable from the connector, and it'll come free without any issue. I even leave the solder that's in there. It really doesn't matter for this application. For my use, the 18-inch cable's typically a pretty good length, so that's what we'll replace it with. But I do like to have some shorter cables for having less clutter on the workbench that I'm working on, so I also make some 12-inch cables at the same time. Of course, we want to start with the same color cable as we're starting for the jack itself, in this case the black. We strip back about this much cable. You need to be able to screw the screw terminal into something, and not too much, not too little. In this case, this is the real trick, is to tin just the end of the cable. If you tin just the end of the cable, then when you screw it together, it'll screw into the cable part and not into solder, and not result in a loose solder joint. Just as a reminder, it's really, really important to use the same color wire as it is to use the jack. If you're going to use this in your circuit, just like the picture shows here, which would you plug it into, the positive or negative? For the alligator end, you want to tin the entire end of the cable, and it is stripped back a little bit less than for the banana side. For the alligator end, it's important to slide the plastic insulator over the wire before you solder the wire together. Here we hadn't assembled the banana end, and we had forgotten to slide the plastic insulator over the banana jack before we assembled it, so we had to push the wire back through from the inside. And it's a little tough because the diameter of this wire is larger, so we used the square pliers to help push it through the hole. It was a little bit of hassle, so it's better to just put it on before you move on. This next step is pretty simple. You just set the wire on top of the already solder blob that's still inside of the Alligator connector and heat the whole thing up with your soldering iron. It'll reflow quite nicely. If you wanted to, you could have cleaned the solder out and replaced the solder and then clamped it if you want, but I think this works just fine. Once you have it soldered and it's cooled enough, and the pliers do help for cooling it, you can then maybe spread it a little farther inside of the pliers and move the plastic insulation up over the cable and Alligator connector. Here's a closer look at the solder connection. It looks good enough, particularly with the strain relief of the insulator that's around the Alligator connector. And here's the final end result. And here's what the cable looks like when it's reassembled. Nice, clean looking little cable. I find it's easiest to do a batch of these at the same time because setup time is usually the longest time in anything you do. And so finish up the same steps for the red and any other cables and connectors you have. So these cables make an excellent replacement for the original cable, quite a bit better current handling capability, and really importantly less voltage drop, plus less intermittency than the previous connector had. It tends to be a stronger connection. In our next video, we'll take a look at why we built these sorts of cables and the value that they provide in real-world testing. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of these cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.